நான் கிளிக் பண்ணிட்டேன். இங்க சுத்திட்டு இருக்கு.
Good morning to everyone joining us. It gives me great pleasure to welcome you all to the Generic Talk series featuring an exciting and insightful session titled Agentic AI in Engineering from Static Models to Autonomous Problem-Solving Systems. In the era of intelligent engineering, education transforms knowledge into autonomous innovation. A heartfelt thanks to our management for organizing such an inspiring series of talks beyond the curriculum. Generic Talk series on every Sunday is a remarkable initiative taken by our management to share the insights from industry leaders, innovators, and visionaries. This platform not only enriches our knowledge but also sparks innovation, bridging the gap between what we know and what we can create. I would also like to express my gratitude to our head of the Department of Science and Humanities, Dr. V. Tamilchelvi, for her unwavering support and invaluable guidance. We are privileged to have this 33rd Generic Talk series delivered by Mr. Arun Prasad, Senior Director and Head of Insurance Solutions USA, and this series is organized by R.M.D. Engineering College. On behalf of our Chairman Sir, Vice Chairman Sir, Principal Sir, Dean Sir, heads of the various departments, faculty members, and the vibrant student community of R.M.D. Engineering College, I welcome you all to the 33rd Generic Talk series. We are honored to welcome Mr. Prasad, who will be delivering today's session on Agentic AI in Engineering from static models to autonomous problem-solving systems. His expertise and industry perspective promise to offer valuable insights into the future of intelligent engineering systems. Sir, we warmly welcome you and thank you for being with us today. Welcome you, sir. Also, I welcome all our distinguished faculty members, dear students, and esteemed viewers who are joining us through our YouTube channel today. It gives us immense pleasure to have you all with us for this enriching session. We are truly honored by the presence of a dedicated staff whose constant guidance and commitment shape young minds and our enthusiastic students whose curiosity and passion for learning bring life to every such initiative. We also extend a heartfelt welcome to our online viewers who are connecting with us from different places through this digital platform. Your presence reflects the power of technology in bringing knowledge, ideas, and inspiration beyond boundaries. This platform has been created with a vision of sharing knowledge, experiences, and insights beyond the classroom. And today's session is yet another step in that direction. We hope this program will be informative, inspiring, and thought-provoking for everyone watching and participating. Once again, thank you all for being a part of this wonderful learning journey. We look forward to your continued support and active participation. Have a great and enriching session ahead. To introduce our esteemed speaker and highlight his remarkable journey, I now invite our Physics Division Head, Professor Dr. R. Priya, to kindly deliver the guest introduction. Over to you, ma'am.
Thank you, madam. I deem it an honor to introduce the speaker, Mr. Arun Prasad from the United States of America, to the viewers. At the outset, I thank the speaker for his consent to be the resource person for today's program. Mr. Arun Prasad hails from Coimbatore, India. He completed his schooling and undergraduate engineering education in Coimbatore and earned a Bachelor of Engineering in Electrical and Electronics Engineering from PSG College of Technology, Coimbatore. He subsequently pursued higher education in the United States, obtaining a Master of Science in Electrical and Computer Engineering from the University of Texas, followed by an MBA from the Leonard N. Stern School of Business, New York University. Mr. Arun began his professional career in the year 2007 with EBIX Consulting in USA. Demonstrating a strong commitment to continuous professional development, Mr. Arun pursued several advanced certifications in insurance and actuarial domains. He has successfully cleared multiple insurance examinations, including probability, financial mathematics, investment and financial markets, and modern actuarial statistics, both MAS 1 and MAS 2, thereby building deep expertise in this field. His professional journey spans diverse domains such as energy distribution and utilities, regulatory compliance, actuarial science, and AI ML driven solutions across business life cycles. He is proficient in handling latest technical tools and programming languages. Few to share, he has expertise in using Databricks, Azure, SQL, Snowflake, R programming, Python, Unix, PySpark, Alteryx, Pandas, Kafka, cloud data migration, Informatica, AI, AWS, Power BI, W, etc. His contributions have been associated with leading organizations including Capgemini, Verisk Analytics, Tata Consultancy Services, MathWorks, and DXC Technology. Presently, Mr. Arun Prasad serves as Senior Director and Head of Insurance Solutions for Capgemini USA. With over 2 decades of experience in applied engineering within the services sector, supported by strong academic foundation, he is a key driver of AI-driven innovation. Mr. Arun specializes in delivering strategic insights to CXOs of Fortune 500 organizations across North America and the United Kingdom, enabling them to convert complex business challenges into strategic opportunities. His influence extends beyond technical expertise to include strategic leadership, market expansion, and the advancement of agentic AI driven transformation and monetization initiatives. Outside of his professional endeavors, Mr. Arun values quality time with his family and actively engages in recreational sports, reflecting his passion for lifelong learning in approachable and people centric leadership style. With these few words of introduction, once again, I welcome Mr. Arun Prasad for today's program. And now I hand over this session to him. Over to you, sir. Thank you.
Oh, thank you so much, Dr. Priya, and thank you so much, Dr. Shalini, for hosting this. I wish that when I was hearing from you about myself, I wish that my wife and kids could have heard it. They're sleeping right now because it's about 12:30, but definitely in the morning they will actually hear. I hope, because you did not. Mince any words in recognizing some of the things that even I've lost long forgotten. But thank you so much. It's indeed an honor, and thank you for the distinguished opportunity to be here and to be present in the R.M.D. Engineering Forum. It's the session that you have led, Dr. Priya and Dr. Amuda, Dr. Shalini and Dr. Chowdhury, is intended to reach many of aspiring students, right? And inquisitive researchers. And I would like to sincerely appreciate and express my gratitude as well. And you also mentioned that the HOD of Dr. Tamal Selvi, who's putting together this forum, is a very lofty goal. I think that, these kind of knowledge sharing, thought leadership sessions is the only way that we can keep abreast on the upcoming the technologies and the flurry of things that the market decides to come our way. So I do hope I can actually make your time well worth and that of audience as well. So we'll talk today a few use cases, right? A few sessions or examples that would utilize core subjects. When I say core subjects, it's basically STEM, right? Math, physics, chemistry, biology. But all these four subjects has to go hand in glove. That would allow for the agentic AI and the age of AI to work together. So essentially, where we are today is that one cannot say that, oh, I'm just a physics person, or I'm a materials person, right? I'm a chemistry person. We are at a point where we are looking at multidisciplinary specialty area that would enable projects. So I'm proud to say that most of you who are listening here are basically in the right path, right? You have a very good STEM program, and you also have the rightful foundation. I'm a beneficiary of those foundations. And today, if I look back in my career, what I learned in my 12th, first year, second year, third year, are so rightfully utilized even today. So just a few months back, I got a chance to open up some of my exam notes and some of the cheat sheets. Not the cheat sheets, but we call it as cheat sheets here. Basically, those sheets I open up from the second year or third year of my engineering college, and then open up and revise one more time, because we are at a point where we have to bring in all of those ideas together to form some things that we can impress to our clients every day. So, in the next 40 minutes or so, my goal here is to restore your faith. You restore your faith in the subjects that you're reading today, and immersing you in a few examples in a real time basis that you see every day, right? So let's get on to the program. I hope you'll stay with me. Um, my mom actually says that I have selective listening problem, right? And I hope I'm actually sharing the right screen. Um, okay, so many times I say that my wife talks to herself all the time, but that's only because she thinks that I'm listening. You know, some of you will get that on the way home, but nonetheless, our topic is agentic AI and seeing what real world examples is, and who other than talk about these, other than Steve Jobs, right? He says that we need to be crazy enough that we can think that we can change the world. And those are the people who can get the job done, in my opinion, right? And that's what he says as well. All others just becomes denominators, or probably bystanders. So you have to ask the fundamental question for yourself, right? If you plan and make what if you plan and you want to make some things happen, um, that's up to you, right? Or the other alternative is you can simply watch what happens, and then wonder what's going on. So, um, with that thought, let's. These are a few pictures from my past years. This picture right here is a college like R.M.D. engineering, right? It's called PSG Tech, and this is my graduation picture. I also spent about a year in IISc, Tata Institute in Bangalore during those days. And I also got a chance to work in Precall because I went to a sandwich program, which is a industry intensive program, which I'm very grateful for. Um, and then I decided to work because, like many of you, I got campus selected, and I went to a place called Noida in Delhi, near Delhi. Worked in a company called DXC um, for about a few years, and then after that, I decided that I'll actually go to pursue my higher education. Um, like most of you, so to do my master's. So went to University of Texas at El Paso, UT El Paso, and then subsequently, after about 10 years after that, went into NYU Stern. So these are some things uh, that that I'm very grateful for to get those experience. So in Tamil, there is a saying, right? it says that something like this, right? It says selvattu payane idal. So which means that whatever you wealth that you have, the only use of that is to give it, right? That's the only use. So with all my education and with all my experience, and that I've gained, I think I've gained those values. And that's the only use of that is to give it back, and which is what I'm trying to attempt to do here, right? So on our own, what Kalam sir has said, he's been an amazing teacher and a mentor, and many of you that we can actually find solace in his own words. The world today is completely in VUCA, VUCA. That's what we call it. V stands for volatility, U stands for uncertainty, C stands for complexity, and A stands for ambiguity. So the people who are successful today are people who think about VUCA and come out very very well, and irrespective of where they sit. And I've actually been sitting in the back bench for a long time. And this is something that I already spoke about. If you see, it's not just about STEM over here, right? All the STEM is like science, technology, engineering, mathematics, physics, chemistry. But it also is today's world also requires business knowledge, insurance knowledge, for example, in my field, um, engineering knowledge, etc., and whichever industry that you belong to. And then also has social sciences and non-technical expertise that you also need. So it's a combination of a lot of these skills. So one cannot say that, okay, I'm actually a computer science engineer, don't give me something that outside of computer engineering. So if you think about most of the software tools today, like take an example of MATLAB that I work for. MATLAB is actually a software company, right? MathWorks. It also has Simulink, and it also has a MATLAB tool. But if you look at where it's applied in aeronautics, it's applied in industrial engineering, it's applied for heavy machinery, for control systems. It's also applied for vehicle stability problems and design issues. So if you think about those tools, it's a computer science tool. It's a perspective that we get because of IT imagination in India, but it also is important that we also take into account that all the other things that's going around. So um, let's actually go into the first fundamental things, right? A few examples are here. In order for you to do anything related to AI, anything related to agentic AI, and go about an autonomous route, the first fundamental thing is that we need to leverage data. From data, you need to utilize some mathematical principles and enable um, statistics. So if you have any questions in statistics, I'm not the best person. I think there are people in the call here. Dr. Chowdhury can be answering those questions. So if you're commenting all those, right? And from there, you go into what we call as AI insights, basically your linear regression models, um, things of that nature, and then eventually go to ML, which is machine learning, your supervised learning or unsupervised learning, etc. And post that comes what we call as artificial intelligence, where you have a whole set of data set, and mostly they are not tabulated, and you're utilizing machines to come up with these pattern matching mechanism that would allow you to compare one to the other very quickly, and then eventually take those ideas, go to the next lever called agentic AI. So it's a big journey, right? So if you look at, you take the data, process it, perform data engineering work. After performing data engineering work, you perform statistics. We call it as exploratory data analysis, which we call as EDA. Once you do the EDA, you come up with heuristics, you come up with statistics, you come up with distribution analysis, you come up with cross correlation, covariance, and those kind of things. Then you slowly go into ML models, AI models, and then eventually go on to onto other techniques and agentic AI. So here we are actually talking about a mechanism where you're looking at the ability to, in a high frequency, take the data, do all the things that I'm talking about very quickly, and effectively provide those insights to the engineer, either he's on site, he or she, or the person who's designing from the behind the scenes, right? So here we are talking about a physical engine um, like an impeller, if you say, or even a aircraft carrier's engine. You can construct something exactly look-alike called a digital model. It's called a digital twin. Just like twins, you will be able to understand what it behaves and what are the different things. So you can probably do a predictive maintenance of agents. So not long ago, I took a flight from Coimbatore, and I was actually going to Delhi, and I got stuck in an intermediate airport for about 8 hours. And long story short, I did not even go to Delhi. I came back. Why? Because there is a tire or some sort of uh, problem in the aircraft, and the aircraft did not even take off. So things like that can be stopped literally, and instead of waste, there's a lot of fraud, waste, and abuse that's going on. Instead of keeping the aircraft idle, or machinery idle, or manufacturing situation idle, you can proactively go about a predictive maintenance, and then have a timely intervention. And that's possible when you do monitoring, perform the controls that's required, operate it effectively, and then you optimize the performance as well. That's in the real environment on the left hand side. And the everything that we talked about in between, the software data layer, the software layer, infrastructure, the data management, models and simulations, everything comes in between, that will connect to the virtual environment. Are you able to follow? So let's give a quick example of that, right? So I'm going to show you a few examples from Capgemini. We have um, we have an engineering division. So Capgemini is a very large organization, about 370,000 people, or 3 lakh 70,000 people working for the firm. One of the firms is, one of the divisions in the organization is engineering. So here we are looking at a high voltage facility. Obviously, a high voltage facility, a power transformer has to be inspected quite often. So you are looking at the performance of it, different design considerations, effectiveness of it, how the voltage fluctuations happen. If there is a surge, uh, how do you deal with the surge? What's the trend like? Things of that nature. So how was the last day has happened? So you see those spots, etc. Those are some of the power electronics work that we have done, that collects the data, right? That's the fundamental foundational principles, where you're able to collect the data. Now you're able to also raise a ticket if there is some issue in it. So in this case, there are about 3 tickets. So the person is able to raise the ticket. And many times, if you look at, if there are electrical engineers in the room, I myself am an electrical engineer. We tend to see the catalogs all the time. Okay, where's the standard? What's the what's the operating conditions, etc. What's the temperature conditions? What's the rates? So you look at those documents effectively in the same place, and then you can have a virtual walkthrough of the entire power distribution substation. And from the power distribution substation, you can pick up these transformers and then see for yourself as to what their models have been. It's very, very easy easy example that many times in India you will see that oh, the power station is shut down, or because a transformer has blasted itself, right? You don't have to wait until that event occurs and then go and fix it. So you can proactively figure out, saying, okay, based on the operating conditions, this thing is going to in a red zone. So why don't we actually increase a work order, and then do a preventive maintenance? There is also three-dimensional view. There's something called as a laser a hybrid, which will allow you to have a mechanism to figure out where the stresses are and where the parameters can be identified in different colors. So the digital twin will be able to identify those tricks. Here you're measuring the height of and the elevation of that particular facility, and very quickly you'll be able to figure out what goes on in the midst. So this is a quick example. And this is a picture. Maybe the picture on the left you should be able to relate with. A lot of physics students, Dr. Priya herself, is a physics person, so she might be working with a lot of these missionaries. This is a picture from my undergraduate school. It was taken recently, and we used to stand in this lab. And then I remember 20 years back, I burnt one of the machines over here, because I did not connect the resistor in the right place. So we had to replace the resistor. I remember that very well, even today, because once you make a mistake, you will never forget it. So that's why I wanted to put that. So it'll be relating to you all. On the right hand side is the place where we used to work every day for the first year, second year, third year, and fourth year, all 4 years. Every single day we used to go to this place here and other such missionary work from 8 to 12, because it's a sandwich program, it's an integrated program, and gave me an opportunity to, right after 12th grade, I started working in the shop floor primarily. And this shop floor is always dirty, always some leaks going on. Heavy engineering division, this is one of the neatest places that's there. It's the motor assembly section, where even before the theory of motor windings came, and that came only in the third year that we were reading. But in the first year itself, we started winding the motors, because they will ask the students as us to wind the motors. And then we know what the impellers are. We know the pumps, because PHG at that time was producing a lot of pumps. So if you get an opportunity, the thing that you want to take away from here is that you'll never know, because I never knew that my future will be around these kind of digital twins, agentic AI, where I'll be using these things. Because when I was going through, I was actually criticizing and making fun of the environment and things like that. But who knows, right? God has a different plan. This is another example. It's a good one, where you'll be able to see quite a bit of work that we have done. I'll probably allow you to see for yourself.
Nowadays, asset revamping has become a strategic lever for industries, improving time to operate. R.M.D 3D, specifically designed asset revamping web platform, offers an easy and intuitive access for a large population of users from any device. Here, the client is facing a loss of pressure and needs to replace a pump. The engineer first launches and user identification.
The same kind of principle that we saw in the previous video, here you're able to see it effectively. And in the design section itself, in the design studio, we with our clients can elaborately see what goes on in the industry flow, chat with the right representatives, and be able to identify what are the components. So in this case, we are trying to replace that particular pump, and those components can be replaced effectively, right?
The electrical connections are correct. The work zone is isolated by the clipping tool to precisely define the region and the element.
Okay, given the time, I'll probably skip this because you'll be able to rotate and fix it and figure out with multiple intuitive ways. And we also have a VR device. You'll be able to utilize that without exposing yourself. Think of it like atomic facility, etc. Right? If you have atomic facility, what goes on, right? You'll have to go and expose yourself. Instead of doing that, you can just sit within the studio. You'll be able to do it. Now let's change the gear a little bit to a different industry, right? We'll talk about the industry that I'm really fond of, which is the financial services industry. So I work in an um, insurance organization, and we are tasked with coming up with unique solutions for the insurance industry. So you might ask, what does the insurance industry has to do with heavy engineering? What does insurance have to do with all or financial um, services need to do with engineering, with electrical engineering, that too, right? Um, it's again going back to the first session that I mentioned about. It's a lot. Everything is a holistic combination. For example, today I use an electric device in my handheld. I'm not sure if you guys are able to see this. This is my computer. This is my cell phone, and I'm connecting a device like this. It's called an IR sensor, right? And it's a small device that gets connected to my cell phone like that. And I can just go around and I'll be able to see a mechanism of what my house temperature looks like, etc. Right? So you'll be able to see quite heavily what the temperature is, where the energy consumption is, etc. So we are using these kind of tools for empowering the end user to automatically come up with an idea of what needs to be insured versus what need not, right? Sometimes if you have a house and in that house you have a lot of jewelry or a fur jacket or your favorite watch that was given to you by three generations down, the value of it is very heavy. So you can take a picture like this, a video, go around, show it to the insurance agent. At the end, they will be able to automatically see everything that goes on and figure out what the right premium value would be. Making sense? So those are some of the things that we can do very effectively with AI. It's called computer vision. It captures a three-dimensional viewpoint, figures out where the riskiness is, and then evaluates what the dollar amount that or the price for that particular equipment is, and then figure out what the sophistications are, and then comes up with a insurance premium that they need to pay. Um, if you don't have these kind of tools, what goes on in today's world without using these tools is that some agent will come home or come to your shop. They go around, walk around, take a lot of pictures, and then eventually write down all these details, send it to the underwriter. They ask a lot of questions. They probably have to have another engagement back. They come back, have a different engagement, and then again go back to the insurance company. Everything takes about 3 to 4 months, right? Now we are trying to solve it within a week. So think of the efficiency that we can get through these kind of tools. And also from an insurance perspective, everything is relatively important from a pricing perspective. So we need to figure out what will happen in a scenario where if there is a fire or if there is a water leak. So think of it. You may not be able to do all the simulations that you want, but given the computers, here we are simulating the level of water raise as slowly as possible. And on the left hand side, if a bathroom is leaking and it goes to the office facility, by the time it reaches the office facility, it takes about 35 to 40 minutes. And by the time when the accident happened versus when it has been told to us, versus when the effect happens, we'll be able to do a simulation based on which it also goes into the network facility room, the storage room, etc. And then we'll be able to analyze what's the damage like when there is a water leak that goes on. And this one requires a computer vision. It requires 3D enablement. It requires engineers, everybody to work together, multidisciplinary sessions to work together and give a view and then quantify certain things, right? So without these kind of tools, whatever the underwriter was saying is what we used to think, or we'll just assume. So by the time water comes in into the basement and then floods the basement and all the major electronics and equipments, it takes some time, and then you can actually see the cost and the area that goes on as well. So I don't want to belabor the point. Let's assume that there is another example here. So we are taking up another scenario. So we go into a basement, and then for some reason there is grease on the floor, and because of the friction, the grease on the floor catches fire. So if the fire happens, how soon or how quickly can that fire expand, versus can there be any fire retardants that could be possible, and how much of the contents that could be damaged. So everything is a mathematical model, right? What's the probability that this event can happen, which we call as peril, and what's the multiplied by the probability of that peril happening multiplied by the value of the content that is exposed to, which we call as exposure, will be the expected uh, total loss. And that expected total loss, if we have to recover over a period of 1 year, that will potentially be your premium. Okay, so that's primarily how the computation works. I hope this gives you some understanding. Let me run one more, and probably this will be a short one. Will give you a little bit more understanding of a very highly sophisticated engineering facility.
Solve production issues or product failures increases companies' competitiveness. This is an inspection technician facing an
Oops.
engine malfunction which he cannot fix alone, despite his long-term experience. To get some help, he reaches a seasoned expert, thanks to Capgemini's and leverages the power of 3D continuity on the field. Malfunction is then identified. Technical data.
Have you ever come across some technician coming to your home and then looking at it and then say that, oh, I don't know about this, right? So I have to figure out a different person. So those kind of situations can be avoided, where a person can take his tablet or a device, can walk through, and a 3D model can immediately be put together. Measures could be done. A person can live speak on the phone and figure out what will potentially be the issue, and also give some guidance as to how they could resolve. So think of it like a very large facility or sophisticated issue. We provide the tools and the ecosystem for doing that, right? That we call as R.M.D. You can just simply search asset revamping on Google. The first thing that you'll get is the Capgemini's solution. So you will be able to see a lot of these things that we talked about today. So asset revamping goes into three-dimensional views, and then gets the laser views, and then gets the building information model, which we call as BIM model, or the CAD models associated with it. So this is a quick summary of what we just saw. A traditional way is to look at what goes on, and the paper file moves from one department to another department. It's slow, and a lot of fraud, waste, and abuse gets done. Now, from a sustainability perspective, this is even more sensitive and much more productive here. So That's primarily what we want to showcase. Some aeronautics engineer and physics will love this. So here's a potential simulation. So you can actually do it in Simulink and MATLAB as well, where I used to work for before. You'll be able to take a drone and figure out what are all the different parameters and KPIs and change those flight simulations on a real-time basis, figure out different operating conditions, and then have a flight simulated done, right? And I don't know whether some of you are able to relate with this. This is a device that we used to use all the time. Again, in my undergraduate college in PhD, I'm sure you also have this Pasco device, which is a universal connector. So we used to use that for all of the laboratories, basically in physics, any of the engineering divisions that you see in general sciences laboratory, you'll have these kind of things which will interface between analog with that of digital. You'll be able to capture everything. So we used to get all the outputs of the oscilloscopes, the function generators, and the power supplies through this, and then provide different interfaces. So the reason why I have this is because it's something that you take it for granted, but many times these are some of the tools that will interface the old world versus that of a new world. So pay attention to it. And this is an example that I kept only for Dr. Priya primarily, because she's in materials and physics area. So we had something that was done from a rheometer. So an assignment for people who are listening to this, if you don't know what rheometer is, please Google and then search for it. I'm not going to explain. But traditional rheometers are very expensive. It's destructive testing, and you get a lot of resins wasted. And these are large resins. And many times, by the time you detect that the manufacturing mechanism to produce those resins are not done correctly, you already waste a whole lot of chemicals and mechanisms. So what we are trying to do is we are trying to put the entire manufacturing process as a digital twin and allow the AI to come and review what are all the different parameters and how it goes, and then see for itself, and so that you don't have to have the physical rheometer, and you don't have to waste a lot of these outputs of the pellets. You'll be able to get those stats and information in the production facility very quickly. So here in this case, the digital clone is able to figure out what's the extruder's feed rates, what are the turnaround times, how many gear pumps are there, what's the amp it's running, how many target pellets are being picked up, how's the extruder's drive motor status, what's the temperature that is there, is it ambient temperature, etc. And then it will detect the viscosity and different principles. So here's a quick picture of my recent visit after 20 years going back to your to the area. We all look different, but the enthusiasm is still the same. Okay. Um, so I think we are halfway through in the session. So I just want to talk about Einstein, right? This guy Einstein was in a train, along with him was an Indian kid. So in order to kill time, they did not have cell phones at the time. So Einstein wanted to have a chat. The kid was smart, right? But he was not Einstein smart, but he was surely street smart person. So the kids placed a bet. He said that, if I don't know your question, I'll pay you $5. But if the question that I ask you, if you don't know, because you're Einstein, you should know everything, you pay me $500. Now, Einstein, after some reluctance, he said, yeah, why not? Right? And after acceptance, so Einstein asked the first question, saying, what's the distance from between moon and the Earth? So the kid promptly took a $5 note and then gave it back to Einstein. And it was kid's turn now. Now, kid asked, what goes in three and comes back down in four? Um, and Einstein thought for a long time. He gave a couple of solutions. He wrote some E equal to mc square, etc. But he could not figure out. So he took his $500 note, and Einstein. The entire journey, he was very busy. The conversation did not proceed at all. But the kid had a very nice time, so he took a $500 note for the kid. But when the station came, Einstein could not hold the enthusiasm, so he wanted to say, "Hey, kid, what's the answer for that?" Now he took another $5 note. He gave it back to Einstein. Right. So this is a game. It's a game of 50x investment. The kid invested $10 and made $500 back. It's called Desi Jugad in our term, right? So the thing is, what you want to learn from here is that even if you're not as smart as Einstein is, you can utilize some of those street smart that India offers to make good on the promises. So you'll be able to do it. Now, if I don't have your attention, and if you have my problem, which is called selective listening, I'm sure that I got your attention with this particular picture, at least with this slide, right? And is a beautiful princess. Why not, right? She's very attractive, and obviously, is something that's worth a listen. So this person went there. She came from Saudi and went to New York City and in Manhattan. And she was actually calling the insurance company frantically, and said that she utilized American Express worth of $1 million in charges, but then someone stole all of the jewelry that goes on. And I've been mugged. Mugging is a word that's used for pickpocketing, but it's a little bit more than pickpocketing. They show you a instrument, um, not the oscilloscope instrument, but instrument like a knife or a gun, and then steal the things that you're valuable. So she was claiming that, and because of a lot of visibility, brand damage of USA, the American Express card had to pay her $1 million back because she was insured. So the insurance company paid. So after some time, this was good, and she was also very happy, and we're also happy that saying, see how good US is. We are able to make good of the promise, right? But long behold, much to our chagrin, it was found that she's 42 and she's not the Saudi princess. She's from Buffalo, New York, and she was working as an investment banker. Right. Today she's in a psychiatric facility in a jail. But the question to you is, okay, how do we find these kind of situation before it happens, a priori, right? What can be spoken about? What are the different data sources that you think? And if you are interested, let's have a conversation. We'll be able to gladly support those kind of work. Um, and that's what we do at Capgemini as well. So, uh, long story short, I want to probably end with the next 2 more minutes saying, look, um, there was a problem in Japan where the fish that they were eating was not tasting very well. And some of you, fish eating people on the call, it's very, very juicy, right? If it is fresh, especially in Chennai, you have a good fisheries area. But what happens is that Japanese population started tasting less of the freshness, and they did not know what was happening. So eventually, it was found that the fish is feeling very, very comfortable. So the fish are born and it's fed, and they're very comfortably eating everything. And then someone harvests it and someone eats it, right? But so Japanese thought out of the box. They are known to think out of the box. So they put two small sharks in the fish tank, in a very large, assume that it's a very large fish tank, right? Now suddenly what happens is that every single fish out there is working for their own survival. So the fish that was supposed to sit from the morning to evening in one place and then figuring out very comfortable food, maybe through Swiggy or Zomato, press a button, the food was delivered. They were not tasting well. So the moment the shark was introduced, now they are agitating, now they are hustling. So it's the hustle that will make you sharp. And guess what? After 6 months or so, the fish started tasting better. So the thing that I want to hear from is that when many times when we are challenged with AI, agentic AI, so many things to read, and if you look at this chart, too many words and too many logos, it takes a long time for you to understand what this is. But if that pressure is not there, we may be like the tasteless fish. So if you want to be tasting good and be fresh, uh, sharks are important, and I think the market itself demands us to be very, very sharp. So so with that, I'll probably ask the hosts to see if they have any thoughts or any questions. Dr. Priya or Dr. Amda or Dr. Shalini?
Yeah, thank you, sir, for sharing your insights with us today. We now
Okay.
hand over the session to Ranjani ma'am for the question and answer segment. Over to you, Ranjani ma'am.
Thank you, ma'am. The first question is, will agentic AI eventually replace traditional iterative engineering design processes or primarily enhance them?
It's a very good question. Very good question. Sounds like the person who was following my presentation. So this is good. Kudos and congratulations. Yeah, I think that it's going to be enhancing all of the processes, and that's a very well thought. Because because if you see fundamentally the processes are all set for a reason. But today, without a human, you will not be able to make a lot of decisions. I'll give you a few examples, right? There was I don't know if I have some time. How many questions do we have before I jump into that bandwagon?
We have three more, sir, but we
Three
can
more
ask
questions.
one more.
So I'll give you a funny example, right? Because that's something triggered in my mind. There is a Taco Bell, and it's my favorite fast food chain, and many of you might know Taco Bell as well. Taco Bell tried to do the agentic AI route, and they went had a voice AI bot where you can actually make a phone call and order the food, or you can actually drive through. And this was a drive through. They had about more than 300, 400 locations that was opened up for this drive through, and they were trying to automate it. And somehow they figured out, it went viral as well. Some of the kids, they started ordering 18,000 cups of water, right? Water is supposed to cost nothing in those firms, and the agentic AI accepted the order, saying, "Thank you so much. Your order for 18,000 cups of water is going to come through. Go to the second window, and you don't have to pay anything, right?" And listening to that story, my son was saying that, hey, these guys should not have asked that. If it was high schooler, they would have asked, "Give me 18,000 cups without water." Right? It would have delivered 18,000 cups without water, and they could have just sold it in eBay. So what I'm saying is, um, traditional processes, it's a long way for AI to perform reasoning. AI can perform reasoning. Autonomous AI can do a lot of stuff, but it's not up to the mark yet. And you'll get these kind of examples that I just gave you. many times, and you cannot actually tolerate those kind of false negatives and false positives. Therefore, human in the loop is a must-have. Therefore, it is enhancing the process rather than replacing a human.
Thank you, sir. The next question is, what is the fundamental shift that differentiates static AI models from truly agentic AI systems in engineering applications?
Right. I hope you saw some of the examples that I showed you. So if you look at a concept called asset revamping, or if you look at simulation for a peril or a damage, you're asking what if scenarios to be generated um, by the AI itself, instead of and which means that the AI has to now synthesize the data. It has to synthesize data. Basically means fake data, right? It has to generate the data, then it has to apply those in a synthetic situation, a hypothetical situation, and none of these are probabilistic models, right? So static AI, the biggest difference between static AI and that of agentic is that now you're looking at everything synthetic, where the AI itself is generating the data set. It's able to perform assessment. It's able to perform your pattern matching, and it's coming up with these kind of solutions. So that's the fundamental difference, where the AI started automating these small utility programs, like a simple thing like exploratory data analysis to figure out, or principal component analysis. Let's say I want to choose the first 5 principal components in a specific data set. And if you don't know what principal component analysis is, please talk to Dr. Chowdhury. He's from maths department. That's what we need to implement. So let's take those 5 principal components. An agent can do all of those without human intervention, which is very dynamic in nature. So that's basically the shift between how we used to do versus the agentic AI world.
Yeah, thank you, Ranjani ma'am. Thank you, sir, for clarifying the doubts. May I now request Dr. K. Amuda, Associate Professor, Department of Physics, to propose the vote of thanks, expressing our gratitude to all who have contributed to the successful conduct of this session.
Thank you, ma'am. Respected speaker, esteemed management, honorable principal, distinguished heads of departments, dear faculty members, students, and participants. Thank you is such a prayer that cannot be seen or touched. It must be felt by heart. It is my proud privilege to propose a vote of thanks for today's generic talk series 33. First and foremost, I thank the Almighty for blessing us with the strength and opportunity to successfully conduct this program. At the outset, I express my sincere gratitude to our management for their constant encouragement and support in organizing knowledge-driven initiatives like this, which bridge the gap between academic and industry. I extend my heartfelt thanks to our distinguished speaker, Mr. Arun Prasad, Senior Director and Head of Insurance Solutions, Capgemini USA, for delivering an enlightening and thought-provoking talk on agentic AI in engineering, from static models to autonomous problem-solving systems. Its deep insights, real-world examples, and clear articulation have greatly enriched our understanding and inspired us to explore emerging dimensions of AI engineering. Thank you, sir. Next, I would like to thank the torchbearer of this event, our respected principal, Dr. N. Anbulchaliyar, our Dean, Dr. K.K. Tyagarajan, for the unstinted support for this generic talk series. My heartfelt thanks to our beloved head of the department, Professor Dr. V. Tamilchelvi, for her constant help and guidance. My special thanks to Dr. R. Priya, Professor, Division Head Physics, for the clear and informative introduction of the speaker, which gave us valuable context about the speaker's expertise and achievements. I would like to sincerely thank Dr. S. Shalini for efficiently comparing the session and for delivering the welcome address, setting the perfect tone of this program. I am now acknowledged Dr. R. Ranjani and Dr. V. Chaudhary for providing excellent technical support and ensuring the smooth contact of this YouTube live stream session without any interruptions. My special thanks to all the heads of departments and faculty members for motivating students to participate actively and for ensuring the success of this event. Finally, I extend my appreciation to all the students, parents, and participants who joined us today and made this event truly interactive and meaningful through your presence and engagement. Once again, thank you all for your cooperation and support. Thank you. Have a great day. Over to Shalini, ma'am.
Thank you, ma'am, for the well-articulated vote of thanks and for your valuable words. Learning today empowers us to design the intelligent systems of tomorrow. May the insights shared today guide us towards innovation and problem solving in engineering. Thank you to everyone, our esteemed speaker, faculty members, students, and online audience. Your participation and enthusiasm has made this session truly inspiring. We hope you leave today with new insights, ideas, and inspiration to innovate you. Thank you all.
Thank you, ma'am. Thank you.
Oh, thank you
Thank you
so
very
much,
much, sir.
Thank you,
everyone.
sir.
Appreciate it.